Hello, my name is Princess Escalante, and I am in Statistics Section D in Adam Heck's class. And today I will be doing a presentation over Starbucks drinks. So in this case, it'll be vanilla lattes versus cappuccinos. So moving on. So why did I choose this data set? Because I personally like going to Starbucks and was curious to know what drink I should get based on the difference of calories. And why is this important to society? It's important to society because people can determine, based on the data, how many calories they are putting in their body by comparing the two signature drinks, because they're very popular drinks, I might add. Okay, a little bit of background. So, Starbucks has been known and made popular because of its tasty drinks. People come from far and wide at any time of the day just to get a sip of their signature drinks. However, many of the Starbucks items can be high in calories, which may affect people who do not look at their daily caloric intake. This is why it is important to do research and compare data in order to watch our individual healths while also enjoying treats like coffee every once in a while. A good article that I would recommend to read about this is called Starbucks Calories Unveiled: What's Really in Your Sips? This is by a health and eating organization called Bistro MD. So there is a URL for your convenience. So the $1,000,000 question is there a significant difference in calories between vanilla lattes and cappuccinos? Okay, so first step in finding out is finding our data values. So um, based on a data spreadsheet that we found, um, I plugged in all of the vanilla lattes, a sample of them, and a sample of cappuccinos. And the first thing I did was I plugged it in my calculator, my TI-84, and I ran it by one bar stats, and I inserted both list slash data values. And then from those data values, we can calculate the rest. So here's more descriptive statistics. So for our vanilla lattes, our sample mean is 124.167, and then we have our standard deviation of 43.84, and then our degrees of freedom, which is n minus 1, which is 12 minus 1, is 11. So for cappuccinos, the sample mean is going to be 85, and the standard deviation is going to be 27.21. And of course, the degrees of freedom are 11. Moving forward, so our hypothesis test results go as follows. So first, we had to come up with a hypothesis. So our null hypothesis is that our population mean equals our second population mean, while as our alternative hypothesis is our population mean is not equal to our second population mean. And we're using a 5% area of significance. So I plugged in the student's T because this time we're using means, we're not using proportions for this. So what I did was I used a formula to find the student's T. So I had subtracted 124 minus 85, and then that was divided by the square root of the other values, which were the standard deviations over the n values, and I added that up and divided it, and that came to a conclusion of t equals 2.629. So that is how I found my t value. My p value, however, I used TCDF, and from there I plugged in my upper and lower values, which is negative E99 and 2.629, and I also plugged in my degrees of freedom, and that gave me a total of 0.01, so pretty much 1%. So that got me to a conclusion that my alpha value, my area of significance, is greater than my p-value. And in this case, we would fail to reject the null hypothesis and conclude that the data is not statistically significant to find a difference between calories in vanilla lattes and cappuccinos. So here are some additional graphics for your convenience. So here it shows the amount of calories in vanilla lattes, and it also shows the amount of calories in cappuccinos, which we see here that is not that different. Literally like 5 or 10 calories difference. So that is all. Thank you so much for listening, and I hope you have a good day.